How you doing? Hi, everyone.
Hi.
How you doing?
Good. Yourself?
Good, thank you. Just got off a class, so just barely made it into my office for this one. I hope you're doing well. The weekend is coming. Hi. Let's check out our lab. We'll start in a few minutes, so I'll give you a few minutes. Just gonna do a little bit of programming today. I posted a couple of things on announcement in case you're interested, but it's more IT than programming. There is a fellowship with the Department of State. So if you want to get into IT, they cover tuition and also give you a job afterwards. Basically, you're going to be working with the diplomacy offices, and some of the offices might be overseas or in the United States. And also there is an IT position at Walgreens Distribution Center. So if you're interested, you can check that out. Let's see, I need to go on Ripple. Okay, so check out the lab before we start, and we'll start in 1 minute. Okay. So in today's lab, we are going to work with sets. I think some people are joining us now. It's 6 o'clock. So we are going to do lab 3 today. Not too difficult, very easy. So we are going to work with C++. If you're looking at your, 1 second. If you're looking at your Canvas, you will find your lab document there. And then let me go into screen share. Okay, so you can check out your lab. Next week, we will break chapter 8 into 2 parts. We are going to do 1 part in unit 4 and then another part in unit 5. So if you want to do some reading at the end of the week, you can read chapter 8, which is the next one. Okay. All right, let's share screen now. So here is our lab. And this week we are going to use Set's library. And Set is an associative container. It contains sorted unique objects. So we talked about last time that there will not be any kind of repeating values. So duplicates are not allowed. So when you're trying to insert the same value as another element, you're going to see that it will not take, right? It will just store one unique value. So the value of the elements in the set cannot be modified once it's in the container. And the elements are always going to be constant. So keep in mind that they are constant values, and once you insert them, you don't modify them. Okay. They can be inserted or removed, and set containers are generally slower than the unordered set container. So there is the sorted set, and then there's the unordered set, which is not sorted. And the way that you would access each of the element is using the index, just like the array. And they would be allowed to do direct iteration. So that means that you can send it through a loop and be able to insert each of the value, or you can insert as a one task. And so the subsets are based on their order. So you can also include the subsets, but the subset is contingent to the index or the location of individual elements. So let's talk about some of the function that you can use, and these are built-in functions. So when I say built-in, that means that when you include that library in your program, you can utilize the functions from that library. And so you simply use the include statement, right? So when you include set, you're able to utilize some of the functions that's built for set. Insert is a way that we can add new elements into the container. And in that case, what will happen is, very much like the dynamic array, your container is going to grow as you insert the elements. So if I start with 3 elements and I'm going to insert 2 more, the container is going to grow as you insert 2 more to be able to fit the new 2 elements into your set. So it's going to effectively increase the size. So unlike the array, the regular array is you have to set a fixed size, right? You would say how many elements that you would want to have. But in the dynamic array, you would see that we would have, you know, it would be flexible to the number of elements that you would eventually have. So you can add it throughout the program. You don't have to start with a certain number of elements. Okay. And then we will talk about other container down the line. So the insertion operation, basically, it's going to check each of the element, whether it's going to be equivalent to the existing one in the container. So if I have 1, 2, 3, 4, and if I try to add 4 again, 4 is already there. It's not going to insert the new 4 to it because it's already the same. Okay. But if I have 1, 2, 3, 4, and I insert 5, then it's going to add the 5 to the container, and it will adjust the size for the container as it adds the new element. Okay. So when you insert an element that already exists, that value already exists, it's going to return the iterator, so that way it knows that there's an existing element that has the same value. So in the back, it's going to have to compare, right? It's going to have to look at what, you know, the existing value, if it's equal to the value that you're inserting. And so so with that, it's going to be sorted, and that's going to how it's going to be able to compare the objects. Okay. So because as you sort the value, it's going to go from low to high value. And so if you insert a very high value, then it's going to refer to the later index to really streamline the process instead of, you know, going through every single element and then compare them. That would take too long. Okay. So that gives you a little bit of background about sets. Then we are going to look at the program. Okay. So let me pull up my program on REPL. One second, it's just trying to connect to my REPL now. There it is. Okay, so let's take a look at this program. And keep in mind that I don't have using namespace std, so I have std and each of the operation here. So if you want to eliminate that extra step to type it out, you can just put using namespace std there. Okay, so all right. I just want to make sure that it's the same one. All right, good. So at the beginning, we are going to include IO stream for the C in and C out for input and output. We are also going to use, and this time we are going to use set. And this is how we're going to be able to utilize some of the function or the method that would come with that particular library, such as insert and so on. Okay. And then if you add in using namespace std, then you don't have to type, like I said, the std with double colon. So we simply have the main function. So when you declare your set, you have to type it. So C++, right, Java are strongly typed language. That means that it has to have a data type for you to create any form of container or and so on. So this is a container. So when I say container, that means that it's just a location in memory where we're going to put the values. So we would create a set called mySet. So this is your identifier. That's the name that you're going to give your container. And you want to specify your data type. So it's going to store integer. So in the case where if you want to make a set that's going to store characters, then you would say char, or, you know, if you want to use longer numbers, you can put long or double and so on. So here we're declaring a set called mySet. And then we are going to use, we're going to declare an iterator that's going to call IT. Okay. And then subsequently, we are going to have we're going to use the pair. Okay. And then we are going to have, again, our set, which is the type. We wanted to say that's going to be the type. And then we're going to use the iterator and the bool. Okay. The bool is that later on, we're going to use it for our conditional statement. The iterator is going to allow us to be able to access some of the elements in our sets. Okay. So in this program, what it's going to do is going to show you multiple ways that you can add elements into your set. Okay. So the first step is to declare your set, declare your iterator, and specify the type and the parameter that you would need for your set. Then next, we're going to have a loop. This is going to be a for loop. And we wanted to automate the process in inserting. So here, using the for loop, there's always 3 parts in a for loop: how you start, where you finish, and how you update. So it's going to start at 1, and it's going to take that 1 and it's going to multiply it by 10. So 1 times 10 is going to give us 10, and it's going to insert 10 into your set. So you would tell it to do mySet.insert. And then we are going to return. So once it's going to go through the loop, and we're going to end up with at 5. So it's going to go 1 times 10, 2 times 10, 3 times 10, and so on up till 5 times 10. So it's going to insert 10, 20, 30, 40, 50 into the set called mySet. Okay. So at this point, if you want, you can actually use a cout, right? And then you can display your set, but then you're going to have to access it. But anyway, so at this point, the set contains 10 through 50. Then we are going to insert another element, but in this one, we are going to use 20. So what you can do is as you declare, right, RET is just another container that's going to hold, right? That's going to be a way that you are going to insert the 20 into to my set. Well, guess what? 20 is already there, so it's not going to do it. Okay. So you can do a mySet.insert and then pass the value, right? If you're doing a single value insert. If it's not unique, it's not going to insert. If it is unique, it's going to add that into the set. Okay. Then what we're going to do is we are going to write a conditional statement. If, right, ret.second is false, then we are going to, because this is the iterator is going to point to, right, the first. Okay. So what happened is we know exactly that 20 is in the second element, right, which is element index 1, but is in the second element, right? So what we're doing is we're placing the position for our set there. Basically, just put a marker there, right? And what we're going to do is we're going to slice our set and we're going to insert in 24, 25, 26. Okay. So what you can do is you can use the iterator and put the position of where you want to insert at a certain part of your set. And in this case, we are going to put it where 20 is because I wanted to squeeze in more numbers in between 20 and 30. So after that, then I'm going to go ahead and insert, right? As I'm using the iterator, think of it like a marker, right? Like in that container. And it's going to put it right after 20. So we are going to put 25, 24, and 26. The reason why this is out of order is I want to show you that set is sorted as a default if you use it as a default. Okay. So after this line, it's going to put in 20, 25, 24, and 26. So that's another way that you can insert is to, if we want to insert in the middle of our set or somewhere in the container, we can use an iterator to do that. Then the third approach is, or the fourth approach is to have an array. And that array is going to hold a group of values, 5, 10, and 15. And then you simply pass the array and how many numbers that you want to insert from that array. So since we have 3 numbers, we are going to do a 3 here. So my int is +3. So what it's going to do is going to take that subset that we have in the array and it's going to put it into the set. If the number already exists, it's not going to insert. If it's not, it doesn't exist yet, it's going to add it. Okay. And then in order to access container that has many elements, we would have to use a for loop. We would have to loop through it to be able to access each of the value and print or see out. So here is the outcome of your program, right? It's going to give me 5, 10, and 15. Well, 10, it was already in there since the beginning for the first loop. So it added the 5 and the 15 with line 21. And then we used the iterator to put right here. And then it added 24, 25, 26. That was happening with line 17 through 19 here, right? Those values didn't exist at the beginning. And then 30, 40, 50 came from the beginning. line 11. So your complete set, right? 10, because you know this one, it didn't drop the second 10 in, and also the 20 here. Okay, because those value already exist. So here's your complete set throughout that program. So this program shows you multiple ways to do insertion in a set, right? Look, and notice that I'm not modifying anything, right? So this loop here, it actually operates the multiplication before it gets placed into that container. Once it's in the set container, it doesn't change. So equivalent to this in Python is a frozen set. That means that once it's in the set, it's inchangeable. It's kind of like the tuple. So it's just a container that holds value, and you can access the value to print or see out, but you don't modify it when it's in there. So question. And if you want to know how to do this in Python, you can take my CIS30A in the winter. It's a straight online class, so pretty easy.
Professor, I'm using the namespace. So when I'm declaring the iterator, I'm having an error message for the it label. Do you think you might know why?
Yeah, so right here,
Yeah.
okay, you don't have to do the STD there.
No,
So-
I'm using namespace. I have that declared. So
okay, and it's what kind of error does it give you?
everything's fine up until the IT.
Right, but it should say something in your error on line 7. What
it's asking for the STD, I guess. I guess I have to use it.
Yeah, you have to use it there.
Okay.
Yeah.
All right. Thank you.
Yeah, the iterator, because that's a special identifier. You have to use it there. So always check your error, what it says. Good job. Any other questions? We'll touch more on Iterator. You're gonna see more exercises on this. So that way, because in like 17B or C, you know, usually you also learn sometime in 17A, it depends on the faculty, but usually in the later classes, you would learn about Iterator. Okay, questions?
Professor,
Yes.
is there, what is the advantage to not declaring namespace and typing them out each time?
There's not an advantage or disadvantage. I think to type it out probably take longer, but it's really based on preference. There are a lot of different type of namespace, but SCD is one of them. It just, you know, sometimes it's really depends on the developer. So in my opinion, it makes it easier for you if you put it at the top, then you can put it at the top. That's the traditional way. I think, you know, also how you're trained. But yeah, it's just a preference.
Okay, thank you.
I know that in our classes here, we teach you to put it at the top, but doing this, you would see that, you know, how namespace is also used. It helps you understand a little bit more. However, that's because in other languages, it's very clear. Like when I see it in Python, like there are ways that we use namespace with the double underscore and so on. So, and in the Python library, it provides more details with their documentation. But yeah, C++ is slightly different. So if you understand that, the other language is pretty close. So, all right. Other questions? Okay, so on for number 1. So once you run the program, I like for you to follow the same example. You are going to try to insert 30, 40, 50, 60. Okay, so you can use any of the technique that's shown there. Okay, you can make a loop, start at 3 and finish at 6, like a for loop. You can create an array like line 21 and 22, or you can, you know, use an iterator. Any choice is fine. Okay. Well, you're going to try to insert 30, 40, 50, 60 again, but keep in mind that some of these values already exist. So do your best in making the observation. Did it add it again? Did it show, you know, two number 30, 240, and so on, or there's only one value? We already know the answer to that. We talked about that. So, okay. So provide your screen capture of the result, but make sure we answer the question. What is your observation when you are inserting these values? And later on in your other programming classes, you know, you would also look at the difference between using a loop, right? Calling a function, or, you know, using a container with another to insert into another container. How is that efficient? Right? That's what CIS17C is designed to do, is look at efficiency and performance in C++. So you can then understand, right, different approaches and how there's an impact in your algorithm for your program performance. Okay. So when we iterate through the program, or it's an iterative algorithm, and that is just looping. Okay. But in the sense where if you are, you can also, you know, call functions, you can do a lot of different things. Okay, so for number 1, try to insert 30, 40, 50, 60, answer the question, take a screen capture. Look at the first example for number 2. You are going to create a setup that contain numbers that are different from the previous exercise. Then attempt to reinsert number. So if you already have it, you can modify it, but if you want to rewrite it, you can, to your liking, of course. You can use this template, and you can insert number like 1, 2, 3, 4, 5, or 100, 200, 300. So for number 2, use the example 1. I want you to create a set that contains numbers that's different from the example. Then you are going to insert numbers of your choice. Then take a screen capture for me, because I want to know that you know how to write a program that use Set STL and know how to do insert. Okay. So if you're lazy like me, I would do this, and then I would try to add in 200, and I would do like a 250, a 240, a 260, and then a 50, another 100, and a 150, like that, right? And then run it. It's different. But anyway, just a thought. Or if you want unique values, you can also do unique values. So you can try to create a set that goes from 1 to 1,000. And you can test the limit of your memory too, right? Like, how is that going to be? Is it going to be able to hold? Is there a limit? Of course, there's a limit. We'll touch on that later on. Any question? No question for number 1 and 2? Okay, so in 1, we already talked about iterator briefly. Here, we're going to see it again because the programs are going to be very close. They look almost the same. Just there's some changes in how we use our values and our functions. So iterator, this is used to access data that's stored in the container or pointing to an item that is part of the larger container. So earlier we use it we mark number 20, and that's how you would use an iterator is you would place, right? You would point to a location of an element or that would have a certain value. Okay, so usually it's just the element location. Returns to the iterator referring to the first element in the set container, because the set container keeps the elements ordered at all time because it's sorted. It would begin the point that goes first in the following container sorting criterion. If the container is empty, like an empty set, then it would return the iterator value. It would not be able to reference any kind of value. That's what it's saying. So an iterator to the first element of the container, that's where it would usually start. So by default, it would go to the first element because that would be at the beginning of your container. If the set object is it's constant qualified, then the function returns const iterator. Otherwise, it returns an iterator. And the member type of the iterator and const iterator are bidirectional iterator that types pointing to the element, meaning that it can go left and right. Okay. So for example 2, shorter. And in this one, what we're going to do is we're going to start with an array. Let's open it up on Rebel. And again, we're using Set STL. And keep in mind that this is just the tip of the iceberg, okay? I don't even go into some of the other operations with this, like union, intersections, and so on. That's more for like other programming classes. I'm just trying to introduce you to Set STL and how you can create a set in this particular lab, okay? But you would see that there are classes that's going to also address this as well. Okay, so for our example, we have an array called myInts, and here we would have values that are not ordered, right? Because array, you can initialize any value anyway. When you create an array, it creates a location in your memory that would slot contiguous space for elements. So now, as this is a dynamic array, right, it will grow with so the number of your elements is going to be the size of that array. Then you declare your set called mySet. Okay, and then you would use your set. You're going to insert, right, all of these values. Okay, but we're going to do it a little differently this time. So in your sets, you're going to have the integers from the array called myInt, and we're going to have 5. 5 elements or items, I should say. Then following, we would have a for loop, and we are going to use the iterator. What we're going to do is we're going to mark it from the beginning, which is the first item, and then we are going to send it all the way to the end. Okay. So here, what we're going to do is we're going to have an iterator. It's going to start at the beginning. And if when it's not the end, it's going to keep marking. So what it's going to do is it's going to go from item 0. Since it's not the end, it's going to do a +1 there. So it's going to go to the next one, item 1, item 2, item 4, and all the way until it reaches the end. So when it reaches the end, then it's going to stop. And then we are going to use a pointer to point to each of the element value using an iterator. So as you mark, so think of it like we would put a marker at the first item, which is element 0, then it's going to be able to point to that and then be able to read the value, which is going to be what you had in your array in the first place. Okay. So this program actually efficiently use memory better than the last one or part of the last one. Okay. So here you're using a pointer. We'll see some more pointer stuff down the line. Okay, run this. So I had it not ordered, right? But when I put it into a set, it is sorted. So there you go. This is another way to create a set and insert value without using insert method. Question? Okay, so once we run the program, I want you to use that, right? You can change 75 element to another value, right? So to something that's different. Then rerun the program and describe the output and on screen. Okay. So if I modify this right here, let's say I make 25. And then I rerun it, right? I no longer have 75. So when I modify this, it doesn't mean that I modify the value in the existing set. This is before it placed the value into the program, right? So when I rerun it, it's just going to put the new value into the set. Now, if I attempt to modify an existing set, then it's going to complain. Okay, compiler is going to complain. Means you're going to get error. Now, what we already know that the same value doesn't duplicate, right? We can't modify the set that's already exists. We can create a new set with new values. Then, so for 3, I just want you to run the program and use different values and see what happens. Provide screen capture, describe the output. Then I want you to edit the, the program, and I want you to clear out like this. Take all of this out. Okay. Let me put 75 back. So clear all of it out and then run and see what happens. Why do you think that is? What is that I'm seeing when I have an empty? I don't initialize. So here I didn't initialize my array, right? And I attempt to put in five items in my set. The computer, it did it. What do you see that I see? Not garbage value, they're memory addresses, memory location. Yours, if you run it on Visual Studio, it looks slightly different, right? Because we're using different GCC. However, the computer, it creates the location for your, right? Because it iterates from the beginning to the end, see? And it made the spot for your value. It just, we didn't initialize the value. So it did what we told it to do. So you seeing, and human was so used to looking at like, oh, that needs to be a number, and it needs to be the right number. Well, it's a location that it created. Just you didn't put a number there, so it can't give you the actual number that you want. Now, in some system, you would see like, 0 times blah, blah, blah. That's usually memory addresses. So this is just referencing memory location. Okay. So when you see a long number like this, that's usually memory. Okay. And that would be for 4. Any question? So STL, the library that you use, it would have many different type of functions that you can utilize, right? You can refer to, C++ doesn't have, proper documentation repository, but there are resources online that you can find that you can use to really look at what each of the function would be and how to use it. Okay. All right, let's talk about number 3 if you don't have any question for, I'm sorry, example 3 if you don't have any question for example 2 and number 3 and 4. Okay, so let's look at example 3. Okay, so this one also we are creating a set. We have a main function. So here we have set STL, we include set, and we declare a set called my set. You've seen that in the last one. We are going to insert 100, 200, 300. And just like the last one, we use the same statement there. We're going to iterate. We're going to use the iterator. We go from beginning to end, right? That's how we're going to be able to get those values in. So, and then we are going to clear. So in this one, you are going to use a function or a method clear. So when you do a clear, in your lab, it says that clear removes all elements from the set container, which are destroyed, leaving the container with a size of 0. So as it clear, right, it's going to shrink down your container, and as it clear everything, you're going to get 0 as a size because there's no items to be put in the set. So after we clear it, it shrinks it back down. Then we are going to insert 2 more. Okay. Then we are going to use a for loop to print it. So we print it here, we print it here. So first we insert 100, 200, 300, print it, clear it, insert 1101, 2202, print it. Okay. So your set is left with only the last 2 elements that you insert because you clear the other ones out. Okay. So the first round we have this, but our final set is only going to be with 1101 and 2202. So then would be, it says that all iterators, pointers, and references related to this container is invalidated. The container is modified and all contained elements are then modified. So the only way that you can modify the content of the set is to insert or clear. Basically, you create or destroy. So now let's say that if I want to change from 100 to 150, what I have to do is, if 100 is already inserted, I have to delete or remove that value, and then insert 150. It will not allow you to update the value for an existing item. Okay, so I want to show you that so you can see there are 2 processes in how you can change the content of a set: to insert and to clear and reinsert. Okay. So after we run the example 3, right? Answer this question: which set is clear? What values were clear? So for number 5, just run example 3 and answer which values were clear. Then for 6, you are going to replace mySet.clear with mySet.insert 0. And then rerun the program. So line 17 gets replaced with mySet.insert 0. And then rerun the program. What happens then? Okay, so we can see that we started with 100, 200, 300. We insert 0, so it drops that in the front. And we didn't clear anything because we got rid of the clear method. So it just add more value to it, add the 0 to the set along with the 1101 and the 2202. Okay. But if we put the clear back, then we would have an empty set, and then it's going to insert 1101 and 2202. Any question? So if you don't like using the for loop like this, you can definitely also, you can use the regular for loop or even for range. It's just in any type of for loop, what you have is you have a start, a stop, and an update, right? We have 3 parts. We have a start, a stop, and an update. Okay, so this is another way to write the for loop using an iterator. That's what it's showing you. But if you want to use the regular for loop, you can definitely do that. Looking back in the other exercises, yeah, you can have a regular for loop. Okay. So as you can see, there are many ways to really solve a problem. Okay. And using programming, we have different approaches. And sometimes, you know, your design and approach constitute the outcome of your application. Not always, but yeah, mostly. Question. Okay, so for 5, we look at what was cleared, answer the question, take a screenshot. We change the clear to insert 0 for 6, provide the screenshot, and then explain the result. Then next, we're going to talk about empty set. If I'm going too fast, then let me know. We still have like another hour, so not in a hurry. Okay, so here we're introduced with another method for the set library, which is empty. And set empty returns whether the container is empty or not, right? So what it does is it checks to see if the size or if there's any element. If you have 0 element, then the size is 0. So the function does not modify the container in any way. So we saw in the last one, if you want to clear the container, then you have to use clear. The return value for empty is either true or false, whether the container size is 0. So let's say that you are writing a program that's inserting, that's automatically storing data, right? Like let's say IoT data, thermostat, um, heart rates, things like that. Now, to test to see if your data is written and, eventually stored into a database or not, we can simply temporarily write it to a container and then take that, extract it from container and then put it into, other location like a database. The way that we would check it is to see if it's 0 or not, right? Because data set that you acquire for those, devices and things like that, it doesn't change, right? It just updates. So at one point in time, it might be at this heart rate, but 5 minutes later, it will be at a different heart rate. So it just continuously adding more content to that set. Okay. So we can use empty to see if our set is empty or not, if there's data that was inserted or not. Okay. So this is now example 4. So this is also another short program. And in this, we are using Set STL. In the main function, we declare my set, and it's holding integer. We are going to insert 20, 30, and 10. Then we are going to print. And we would say we would use a while loop this time instead of a for loop like what we've seen. While my set is not empty, point to the beginning of my set. And as it does that, erase. Okay. Here we go. So my question for you is, what happens after the while loop? Is 10, 20, 30 still there? Are we efficiently using memory? Okay. So first we insert 10, 20, 30, right? We have a while loop. While it's not empty, point to the beginning of the set. And then start with the erase beginning. But when you show it on REPL, yeah, it shows it there because you print before. This is going to give us the print already. So what happens after it prints? All right. So look at that example. I want you to run it. Notice that the while loop is using what's set empty function. Explain the while loop purpose and how it would relate to your output.
All right, so Professor, I have a question just for clarity.
Sure.
When it comes to, I guess, for the iteration, it seems to be a rule to use the std command. So is it the same when we're doing set? Do we need to use the std double colon set? Because I haven't run into
Yes.
any error. I haven't run into any error issues. I was able to just use regular set
Yeah,
and the angle brackets, but with iteration, I had to use double colon.
right.
So,
Because yeah, for iterator, you would have to use STD. But if you use using namespace STD here when you declare a
Right.
set,
right.
because it pulls the library already, you won't
Mm.
have to specify that. The iterator, because that's that's coming from just GCC, so yeah, you will have to specify the
Okay.
namespace for it. Mhm.
Okay. All right. Got it. Thank you.
Yep. And then, so for your assignment, right, the last part is to look at the while loop. Remember that there's a not operator here. So what is it really checking for, right? So the while loop, it's always going to be running if the condition is true. So in the case of my set, I only have 3 elements, 10, 20, 30. So as it's going to go and look, first item, it's not empty. So it's going to execute. It's going to access. So it's going to point to the beginning, which is 10. And that's how it's going to be able to see out, right? Using a pointer. Then second, and as it does that, it's going to erase it. So I would have show 10, erase, check if it's empty. If it's not empty, then that will be 20. So 20 is then the first one. So you going from 10, 20, 30. Once it prints 10, it's gonna erase that 10, 20 takes its place. 20 becomes the first. So it's still gonna be at the begin, right? And then it's gonna print 20, erase 20, 30 is then gonna move into the first item place. Then it's gonna print 30 and erase that. So at the end, I don't have any values left. Okay, so when you point here, you're only going to point to the first location. Print, erase, 20 move into its place because it shrinks it down, right? And then print, erase, 30 moves into its place. So there's no need to go from begin to end if you're going to print and then erase. Okay.
So then it sounds like you're essentially not using any memory.
Well, you give it back. You did use some, but you give it back. Yes.
Okay.
And that's the whole point. So when you do return 0, anything that was utilized for the variable, it would release it to the system anyways, ideally. Okay. But when they assess, when they look at the process in your program, they're going to have to say, okay, how efficient are you with because if you started using a lot of different container that you don't release, what's going to happen is it's going to run that application, you're going to have to require a lot of resources, right? And this is what you see with applications that require more RAM and so forth, because it needs to use it for a specific task. And in that task require processing and resources and so on. So we want to give it back. Sure. Programming, development is about using memory, right? All of these things, it's just container, it's just a location in memory, put the values there, go to it, pull it, and then be able to do something with it. Traverse to it, look it up. Yes, what's going
So
on?
essentially with this method, you're using the same amount of resources because you keep giving it back for the next number.
Exactly. The only time that you have the most resource is the insert. So it when you insert, you insert 1, it makes it room for 1, insert 2, it makes room for 2, insert 3, it makes room for 3, right? That's the most part. And then after that, everything, so it's going to shrink it down one by one and then give it back. So at the end, nothing. That container doesn't require any storage at the end. Empty. So, another approach is I can insert and then do it like the other one, right? Do a for loop, print it out, and then you want to clear it. Then you would then move everything to 0. Okay. So it exits the loop after you erase the number 30. It becomes false there because it's empty now. Then it exits the loop. Okay. So in both approach, the previous example and this example, we release that space, right? Like when you clear it, you put your container down to size 0. It doesn't hold anything. And then also on this one, you erase and we would check for empty. Okay. Yeah, C++ doesn't do garbage collection well compared to other languages. Java does and Python does. So, when you have a very lengthy program that require a lot of resource, just to be mindful about your resource usage for C++. Any comment or question? Okay, pretty easy, right? I don't want to scare you off. You should have seen the lab that I've written, before this. So this is like version 5 of CIS7 lab. And, I refine it over time. I think in the future for lab 3, I want to probably touch on some more operations down the line. But at the same time, going into this class, many of you just took CIS5. Some of you took more programming than other. So I don't want it to be very difficult for you to really understand. I think if we start with the basic and then eventually you're going to see that the programs are going to get longer and it's going to be more complex. And at the end, you will still see class and stuff like that. So I will build you up to something more advanced. But I rather that you understand the very basics so you would know how to write it on your own versus, trying to attempt something very complex to start or a little bit more intermediate to start. So I think it's good right now for us. Okay, and if you want to try other methods, you can always use resources online to look it up and be able to use it and play with it. And that's, I encourage you to do that. Okay. Questions? All right. So if we're finished, you can type your name into the chat. I'll stick around for question as though we have another hour. But I'm going to stop recording so I can put my YouTube video up.